Hi, I'm Bill Malik, Chief System Architect with Enterprise Web. We're going to be giving you a demo today that's part of the Intel Testbed Extreme Automation at the Edge, where we did a 5G RAN testbed with a secure edge gateway use case. In this particular demo, though, I'm going to focus on the service-oriented SON that was delivered by pairing Enterprise Web with KX AI and ML capabilities. To realize the SON, Enterprise Web deploys KX and programs it with models representing all the elements in the use case. Then it actually configures it to observe all the state and telemetry from those elements so that it can process the signals and eventually send back to Enterprise Web signals so that it can adjust things in the environment to impose a closed loop. In this case, it will actually go and configure all of the different elements to deliver an optimized solution. The demo will be delivered in 4 parts. 2 day 0 elements. One will be onboarding, one will be composition. Then we'll go to day 1 deployment, and finally we'll dive into the SON operations. So here we're logging into one of the Enterprise Web modules that you used for onboarding and managing code packages, XNFs, controllers, and things of that like. Each row in the catalog is an individual object. You can search them all in a Google-like way, find things based on either names or capabilities, those kinds of things. Each one of the elements that you see here in the catalog was onboarded in under an hour. They provide a full model of basically all the things that are needed to, of course, deploy and manage the life cycles and even do the overall management, like the governance over these things, versioning, security, and all of that. But what's important is that they have the full model of both the deployment and the behaviors of each one of these components. Here we see a firewall, for instance. Behind that is a rich model that allows us to graph connect each one of these elements, and really importantly for this, we can train KX on how to optimize each one of these components. Once we have all of the elements in the catalog, it makes it really easy for a service designer to then log into Enterprise Web. Here they're using a slightly different module that's used to actually compose the services that they want. So in this case, you can see things like cloud hosts where things might be deployed. Of course, the service that we composed is going to be in this catalog too now, along with all the elements that we're going to compose. And really what we're going to do now is just quickly look at what that service designer does. They basically pick out the elements that they wanted from the catalog, each one of these with a model that understands how they can be optimized, as well as, of course, deployed and lifecycle managed and all that. They compose the elements that they pick into a graph down here and supply any sort of overall context. So if they want to come in and actually declare intent, here we're drilling into one of the, in this case, connection, and we could configure things like service chain elements and policies and so on. Of course, then we can actually go in and individually describe intent for each one, right? We're popping in here to the Aether stack, which is the RAN stack that we're using. You can see the interfaces here that have all been declared. The system can go in and do things in this kind of a case, like actually secure the control plane. But importantly for the SON here, we can actually declare at a high level the kinds of intents it's going to have. What does it maximize? Effective throughput for this component. What does it minimize? Things like resources and so on. So the system will take those few inputs, those few intents, and deliver this closed loop you see here around the 5G core components. So the next part of the demo, we're going to go into day 1. Enterprise Web provides REST APIs that are generated for managing the service as a whole. Here we're going to use one just to deploy the service so that we can see our SON in action. So we deployed the service. You can see it's already in the inventory here. And if we wanted to, we could actually pop into OpenShift to see it being deployed in real time. And then coming back to the system, we can actually examine a trace that the system provides, which gives us basically details on any LCM event that occurs. Right now there's just the instantiation, and if we wanted to pop into it, we could actually see each of the individual commands that are being run. You can see here, I think it's a couple of order of maybe 100 operations. Again, these are all executed as a transaction. and they represent thousands of micro operations. But really, if anything fails in here, it'll roll back with transaction guarantees, all that kind of good stuff. But in here is also the deployment of not just the service, but the configuration of all the components, including the SON, so KX, and all of that. And we could even start using this service if we want, which you'll see right here. Just placing a simple call. You can see me here. I'm going to activate the video here for the service. And what we want to do here for the demonstration actually is show you the power of the SON itself, right? So we're going to go to day 2, and you're going to see the SON operation. So to demonstrate that, what we did was we deployed the SON, but we temporarily disabled all the policies in it. So you can see a KX dashboard along the bottom. It's following certain levels of telemetry and so on. And then there's a threshold on the bottom, that yellow line. You can see all the signals are well below. Everything right now is good. What we're going to do is we're going to simulate 50 gigs of traffic, attack traffic with 5K users. And what you're going to notice is that the signals on the bottom are going to spike, and almost immediately my video on the right is going to cut out. So this is going to start in a second. So what's going to happen is you're going to see the effects basically without a SON in place. The system's overwhelmed, configuration, load, all that kind of stuff are being stressed. So here we go. We're going to start the demonstration. So we start the simulation of the traffic, and then as soon as that simulation starts, you can see on the right there's no more video, and you can see there are signals here that are being spiked. Now as soon as we go back into Enterprise Web and we use that API interface we had earlier, we're going to activate the policies on the other side of the SON. So as soon as KX sends those signals to Enterprise Web, they're not going to be ignored anymore. They're going to start to actually result in that closed loop that you saw before depicted. So we're starting those policies, and then as soon as they really kick in, you're going to see, okay, my video's back on the right. That's great. A wave, hello. What's important though now is that we come back in the system, besides the fact that all those levels went down and everything, you can see a bunch of SON signals, a bunch of lifecycle management operations for healing that took place. And if we want to, we could go in and see at a granular level, just like with the deployment, how the NIC was reprogrammed in this case to prioritize attack traffic and improve our throughput and reduce the power consumption. So adjustments like this are continuous, so we have an always optimized service in this kind of a case that's not just giving us good performance, but is actually minimizing the power we consume. So over the course of the demo, you saw me go from onboarding the elements that were going to be composed. In the first phase of the test bed, we actually implemented at 1 gig per second without the SON, which gave us a good baseline with which to compare our stage 3 results. And we were able to find that even at 50 times more traffic, when we're using the SON, we were actually able to do more with less. We were able to increase the performance, so better latency, and actually even lower the energy and resources consumed.